In this video, I'll discuss how to work with scheduled jobs. In Linux, there are three ways that we can schedule jobs. The first is using cron. Cron is designed for running tasks on a regular and recurring basis, such as hourly or daily. At is designed for scheduling a single job to run at some point in the future. Systemd allows us to run jobs on specific events or time intervals, for example, every 5 minutes or maybe 10 minutes after the system boots. Newer versions support calendar timers, and this gives us the same type of functionality as cron. Cron is handled by the cron d daemon. Jobs can be added by any user that has permissions. In /etc, we have both a cron.allow and cron.deny file that can be created. Inside each of these text files, we would have one username per line. So if the cron.allow file exists, then the cron.deny file doesn't even get checked. However, if the cron.allow file isn't there, then users listed in cron.deny cannot use cron. So either you have a list of who's allowed to use cron or who is not. Cron jobs are stored in the cron tab file location, which is /var/spool/cron. We shouldn't edit these files manually. Instead, we should use the cron tab command. Cron jobs are accurate down to approximately 1 minute. So if you want to schedule something to happen every few seconds, you can't do that with cron. Instead, you might consider using a systemd timer. Cron tab entries are specified in a text file with 5 fields starting from left to right. On the left, we've got the minute, followed by the hour, the day of the month, and the day of the week. Now, the day of the week can be used numerically. For example, 0 we could reference as Sunday, or we could put in sun for Sunday. Take note that both 0 and 7 reflect the day of the week, Sunday. We could also use an asterisk in any of these 5 placeholders to mean, for example, every minute if it's in the minute placeholder section. Or we might use *10 in the minute placeholder, which means every 10 minutes. The @scheduling command is used when we want to schedule something once and not on a recurrent basis. @jobs are handled by the @d daemon. Users have to have permissions to schedule these one-time jobs, just like they do with cron. And in the same way, under /etc, we have an allow and deny file for @. Jobs can be queried and removed from the command line. When we schedule an @job, we can give it a date or a time. For example, we might type in at the command line @9:00 p.m. to run a job at 9 p.m. today. The command can understand some natural language statements, such as @noon would run the job at noon, or @now plus 15 minutes would run the job 15 minutes from now. Systemd can schedule jobs at a relative time. For example, to start a script perhaps 10 minutes after the system has booted. With systemd, each job requires 2 config files. One is the service file that specifies what it is that needs to run, and the second is the timer file. The timer file specifies when to run the job. Job configuration files for systemd go under /etc/systemd/system. The accuracy is set to 1 minute by default, but you can get very granular, much more granular than cron if you wish, with systemd. You can get down to a microsecond. In this video, we discussed how to work with scheduled jobs. In this video, I'll describe how cron schedules jobs. At the command line, I'm going to type man space cron tab. This is going to give me the manual page for the Linux cron tab command. Here we can see it describes the fact that the cron tab command is designed to maintain cron tab files for individual users. This would let users schedule jobs. And as I go further down through the manual page, I can see the command line options. For example, cron tab -e would edit the current user's cron tab file. I'm going to press Q. This time, I'm going to type man space 5 space cron tab. What this means is that instead of getting help about the cron tab command itself, what I'm looking for is help about the configuration file cron tab. Now I see I have a different manual page than we were looking at previously. Here it's talking about the cron tab file, which is used to schedule cron jobs instead of the cron tab command itself. As I go further down through this manual page, I will eventually come across an area where it explains from left to right what the values mean in a cron tab file. And it tells me that starting from the left, we can specify the minute that a job should run, the hour, the day of the month itself, and finally the day of the week. So here I can see I can use names for the day of the week, same thing for months, and the others are numeric values. The manual page then continues to go on saying that I can use an asterisk, for example, for every minute, or every hour, or every day of the month. I can also use ranges of numbers. So for example, 8 through to 11, perhaps for hours. I can also use lists of numbers, comma-separated lists or comma-separated ranges. I'm going to press Q to get out of this cron tab configuration file manual page. I'll clear the screen, and at this point I'm going to type ls/etc/cron asterisk, and I'll press enter. Here we can see that in the etc directory, we have a number of files. For example, cron.deny list usernames, one per line, for those users that should not be allowed to use cron. But under etc, I also have a system-wide cron tab file. Then I've got other subdirectories under etc, such as cron.daily for daily scheduled jobs, cron.hourly for hourly scheduled jobs, and of course cron.monthly for monthly scheduled jobs. Let's take a look at the system-wide cron tab file. I'm going to type cat space /etc/cron tab. In this cron tab file, we can see we've got a couple of variables such as the shell being set, the path, and so on. Then we've got a number of comments. The pound symbol at the beginning of a line means we have a comment in a file. And it's telling me that the leftmost item would be the minute that I want to schedule something, following on the right, the hour, then continuing with the day of the month, and the day of the week. But because this is a system cron tab file, in other words, it's not specific to one user, we then, after we specify those date and time ranges, would specify a username that should run the scheduled job. Then, the last parameter within this system cron tab file is the command to be executed. That could be a Linux command, it could be a reference to a shell script, and so on. I'm going to clear the screen again. And this time I'm going to type ls-ld space /var/spool/cr asterisk. What I'm doing here is displaying the entry for var spool cron. This subdirectory is where user cron jobs that get scheduled would be stored. What we've just looked at is the system-wide cron tab file. Cron is controlled by a daemon. I can check the status to make sure that the daemon is running at any point in time. For example, here at the command line, I'll type /sbin/service space cron d space status. When I type this in, it should return whether or not the service or the daemon is active and running, which it does report is true. It is active and running. In this video, we described how cron schedules jobs. In this video, I'll demonstrate how to schedule a cron job. The first thing we'll do is we'll schedule a system-wide cron job in the system-wide cron tab file. So what that means is here at the Linux command line, I'm going to edit the /etc/cron tab file. I'll do that using the vi command line text editor. Here in the system-wide cron tab file, I'll press insert so I can modify the contents within this file. Then I'll add a new line at the bottom. Starting from the left, I have to specify minutes, hours, day of month, month, and day of week when I want something to run on a recurrent basis. What I want to do is build an audit trail of users that are logged in. Now, normally I might do that once a day, every few hours, once a month, but here I'm going to have it run every 2 minutes so we can see the result. So because minutes is the first or leftmost placeholder in a cron tab file, I'm going to type */2 for every 2 minutes. Then I'll type a space, and I'll put in a star for the hour, space, a star for the day of the month, space again, star for the month, and star for the day of the week. So I want my commands, which I haven't yet specified, to run every 2 minutes, every hour, every day of the month, every month of the year, and every day of the week. Then I'll put in a space, and now I have to specify the username under which the command will run. I'm going to put in root, then I'll put in a space. Now I have to put in the command or commands that I wish to execute. They could be raw Linux commands, or we could reference a shell script. Here I'm just going to use raw Linux commands. So what I want to do is use the date command to append to a file on the root called loggedinusers.txt. I'll type in a semicolon, then the next command I want to execute is I want to run the who command, which shows me who's logged in. And I want to append that to the exact same file. So my file on the root called loggedinusers.txt, every time this cron job runs, will have a date and timestamp under which we'll then see a list of users that were logged in. Now I'm going to have to go ahead and make sure that we specify that. Looks good. And I'm going to save it. Going to press escape, press :WQ. And at this point, cron will realize that there's a job that should run every 2 minutes. And so it will begin doing that at the next cycle. We'll come back and check for that file on the root of the file system in a moment, because currently, if I try to cat/loggedinusers.txt, it says there's no such file or directory because that cron job hasn't yet run. In the meantime, we're going to create a cron tab for the user that's currently logged in, which is root. Root is always allowed to make cron tab entries. With some Linux distributions, such as Red Hat Enterprise Linux 7, by default, root is allowed to configure cron jobs, but other users are not. So to create a user cron job, we would type cron tab space -e. The E means we want to edit. When I press enter, it's going to put me into a blank new user cron tab file. Now it won't be blank if the user already has things they've configured to run on a recurring basis. So I'll press insert so I can modify the contents here. Essentially, what I'm going to do here is type star or asterisk space asterisk 1 space asterisk /2 space 0. So basically, what I want to happen here is on the first day of every second month, I want something to execute. What I want to execute here is I want the history-c command to run. This will remove the command line history. Now, in a user cron tab file, you don't specify the username like we did in the system-wide cron tab file. So that's why I went right to the command. So I'm going to run history-c semicolon. Then I want to echo history cleared on, and I want the date. So for that to happen, I'll put in $ open parentheses date, close parentheses. It'll run the date command. Close my double quote, use my output append symbol, and I'm going to go to my home directory, which is referenced by the tilde. I want a file there created called history.log. Basically, I want this log file to have a record on the first day of every second month when it clears my history. This is going to be a cumulative file because we are appending to it. So I'm going to press escape, then :WQ to write and quit. Now, we can type cron tab -L to list any user cron tabs. And indeed, it shows us what we've just done. User cron tab files are actually stored under /var/spool/cron. So when I ls that location, you can see that we have a file there for the root cron tab, for user root. We can also remove user cron tabs by typing cron tab-r. So now if I were to type cron tab-l, we can see it tells me that there is no cron tab for user root. Now, let's see if on the root of the file system our first system-wide cron job has executed yet. I'm going to type cat /logged in users.txt, and we can see that it appears that the job has run twice. In this video, we learned how to schedule a cron job. In this video, I'll demonstrate how to manage cron jobs. When we schedule recurring jobs with cron, we have options whereby we can edit those job details. We can even pause cron jobs from executing. The first thing we'll do here at the Linux command prompt is type vi /etc/cron tab. This is going to open the system-wide cron tab. I'll then press insert so I can make changes to this cron tab file. There's currently a job that's set to run every 2 minutes on the first day of every month. However, I want this to happen every day of every month, every 2 minutes. So I'm going to change that one in the third placeholder position to an asterisk. So now I have a job that's going to run as root that's going to append the Linux date and time, as well as a list of who's logged in, to a file on the root called logged in users. So we can edit system-wide cron tabs. Now to save the change, I would press escape and type :WQ. At the user level, I could type cron tab-e. This lets me edit my user cron tab file where I will see any existing cron jobs. Currently, I see a job that's set to run every 10 minutes on the first day every second month. And what it's doing is clearing my command history and then writing a message to a history log file. Well, what I'm going to do is make sure that this happens every 20 minutes. So I'll press insert to go into insert mode, and I'll change the */10 to */20, which means every 20 minutes. And I'll go ahead and press escape and then :WQ to write and quit the change. Of course, I could type cron tab-l to list any of my cron tab jobs as a user. And we can see our changes reflected where our user cron job will run every 20 minutes now instead of its previous configuration of every 10 minutes. We can also remove cron jobs by typing cron tab-r. When I do that, if I try to run cron tab-l again, it tells me that there's no cron tab for user root. Another option is to rename cron files if you don't want jobs in them to be executed. So that means I might rename /etc/cron tab to a temporary file name if I don't want any of the system cron jobs to run. The same thing would be true for user cron jobs, which get stored in /var/spool/cron. Currently there is nothing because we've just removed the user root's cron job, but we could rename the files to something else. And then there's always the option of working with the cron daemon itself if you don't want any cron jobs to be executed on the system. For example, I'm going to type /sbin/service cron d status. We can see the cron daemon is currently active. Cron is always set to auto start, but I could stop it if I wanted to. I'll bring up the previous command, and I'll change it so that it reads /bin/service cron d stop. So I've stopped the cron daemon service. Now, understand, of course, that there are no cron jobs at all, whether they're user-based or system-wide, that will execute on this Linux host. I can verify that that daemon isn't running by typing /sbin/service cron d status, and we'll find that it's listed as being inactive. Now I'm going to start up the daemon again. So my command for that will be /sbin/service cron d start. And we'll just check the status again. I'll bring up that command with my up arrow key. And lo and behold, it's listed as being active and running. There is another way where we might choose to pause the cron daemon instead of actually stopping it. The first thing we'll do is type ps-aux, so I can list all processes, including user processes, and the lowercase x means processes that were started as background daemons. And I'll pipe that to grep because I'm looking for cron d. We can see that cron D is running and it's got a process identifier or a PID of 40167. To pause it, I could type kill space dash stop. The word stop is in uppercase letters, followed by a space and our PID of 40167. Now, if I bring up our PS command again, notice in the status column where we used to have an uppercase S, we now have an uppercase T. The uppercase T means that the service, or daemon in this case, has received a signal to stop running. And of course, that's a result of our kill command. Now, to bring that daemon or service back online so it's continuing to process scheduled jobs, I would type kill space dash CONT for continue, that's uppercase letters, and our PID of 40167. In this video, we learned how to manage cron jobs. In this video, I'll demonstrate how to work with the AT command to schedule jobs. In Linux, the AT command allows us to schedule a one-time non-recurring job. The first thing we'll do is verify that the AT daemon is running. So I'll type /sbin/service space ATD space status. We can see that its status is listed as active and running. So the next thing that we'll do is we'll examine /etc for any files that begin with AT. So my command is ls space /etc/AT asterisk. I can see here that under etc there is a file called at.deny. If I cat the /etc, at.deny file will see by default that it's empty. Much as is the case with the cron daemon, we can build an at.allow file as well as an at.deny file, where within those files there would be a username, one per line. So if the at or at.allow file exists, then only the users listed in that allow file are allowed to schedule jobs using the AT command. So in other words, the at.deny file gets ignored. But if the at.allow file does not exist, which is the default, then users in the at.deny file are not allowed to schedule jobs. Syntactically, we schedule jobs at the command line by typing at space, and then we specify date and time information. For example, here I'm going to specify 4:00 a.m. So in other words, I want to run a job at 4 a.m. today. Now, if that time today has already passed, then whatever commands I specify, which I've not yet done, will run tomorrow at 4 a.m. I'm going to press enter. Now, when you begin scheduling an AT job, it puts you into an interactive AT command prompt. From here, it's waiting for us to specify the commands, one per line, that we wish to execute at that specified date and time. All I want to do in my case is run rm space -rf/tmp /*. In other words, I want to clear out my temporary file directory. Now, when I press enter, it then continues because it assumes I have more commands I want to run. If I don't, what I would do is press Control D. At this point, it tells me that job 1 is now scheduled to run. Let's look at a couple of other syntactical examples for scheduling AT jobs. I'm going to type at or AT space noon space today. So it can be very English when it comes to the syntax. Maybe what I'll do at noon today is I'll run the who command, and I will use output redirection to create a file on the root called lunch_workers.txt. Now I could continue with more commands, but I'll just press Control D. Now we have job number 2 that's been scheduled. I'll do one more example. Here I'll type AT space 6 a.m. space +1 day. So I want this to be scheduled to run at 6 a.m. tomorrow on the following day. So as always, when I press enter, I'm then placed into an interactive AT command prompt. Maybe what I'll do here is run the who command and use output redirection to create a file on the root called early_birds.txt. And I'll press Control D to end it. So now I've got job number 3 that's been submitted. I could type ATQ to view up all the queued jobs that I've created. In this video, we learned how to work with AT to schedule jobs. In this video, I'll demonstrate how to schedule an AT job. In Linux, we can use the AT command to schedule one-time jobs. The syntax after the AT command would be the time that you want the job to execute, followed by a space, and then the date. For example, at the shell, I will type AT space 10 p.m. space Jan space 30. So I want this job to execute at 10 p.m. on January 30th of this year. When I press enter, it places me in an AT interactive command prompt. All I'm going to do here is use the tar command to create a compressed archive. So I'll type tar-czvf space /backups/ yearend.tar.gz. So that's my end result compressed archive file. Space, then I have to tell it what it is I want to archive and compress. So I'm going to put as the last parameter /user files, and I'll press enter. I also want to echo back a statement to a backup log. So I'll type echo space open double quote. Backup completed on $ open parentheses date close parentheses, because I want the actual date and time when this occurs, written to a backup log file. So I'll use my append operator, which is 2 greater than signs, and I want this backup log file to be under /backups, and I want it to be called log.txt. Really, we could be using any relevant Linux commands to serve our purpose. Now, after I press enter a second time, I'm still at an AT interactive command prompt, but I'm finished. That's all I want this job to do on the 30th of January at 10 p.m. So, to tell it I'm complete, I would press Control D. And it tells me that job number 10 has been submitted. This tells me that other jobs have been submitted previously on this system. They might have already run, but it's assigning job IDs based on what's already been assigned. So that's why we didn't start at job ID number 1. I'm going to do another example. So I'll start by typing clear, and this time I'll type AT space now space +1 space min. So I want something to execute 1 minute from now after the job has been submitted. So I'll press enter. And again, I'm placed at an interactive AT command prompt. What I want to do this time is use the find command. So find space /name. And in double quotes, I'm looking for files owned by C. Blackwell. So I'll put in the name C. Blackwell. And I'll use my output redirection symbol. And I want to store files owned by user C. Blackwell under /user files /C. Blackwell files.txt. That's all I want that command to do, so I'll press Control D. Now it tells me job 11 has been submitted. We can also take the contents of a file in which we've already placed Linux commands and feed that into the AT command. For instance, I'll clear the screen here. Now I'll type cat /user files /at_commands.txt. This is a file I've previously created, and it can be called anything. In it, I've got an echo statement, and I'm writing that out to a file, and then I'm using the init /6 command to restart the Linux host. So I want to schedule those commands. I want to restart the Linux system, but I want it to happen in the future without me doing it manually. So I'll type AT space -F. Now this is new. Here, after the -F, we'll add a space and we'll give it the path and file name of our file with our Linux commands in it. So here that will be /user files /at_commands.txt. But I still have to specify when I want that to happen. So in this case, I want that to happen 1 hour from now. So I'll type now space +1 space hour. And it tells me that job number 12 was submitted. We can type ATQ to view jobs that are queued to execute. Here I can see jobs number 10 and 12 are set to go. You might wonder where our previous job went. We had a job that was scheduled to run 1 minute from now where it was searching for files owned by user C. Blackwell. Well, that already executed, so it's been removed from the AT queue. However, we should be able to verify the existence of a file called /userfiles/cblackwellfiles.txt. So we know that that file does exist, and if we actually cat that file to view the contents within it, it should list any entries owned by user C. Blackwell. So the command did run, and then it was removed from the AT queue. In this video, we learned how to schedule an AT job. In this video, I'll demonstrate how to manipulate an AT job. The Linux AT command allows us to schedule a one-time job. After jobs have been scheduled, we have a number of related commands where we can manipulate those submitted jobs. The first of those commands is ATQ. When I type in ATQ and press enter, I'm viewing any AT submitted jobs that have been queued up. Now, these jobs haven't yet executed because when an AT scheduled job does execute, it gets removed from the queue automatically. Here I can see I have two jobs, jobs number 10 and job number 12. Now, if you're wondering what happened to 11, it must have already run. Now, we can also see specifically when these jobs are scheduled to run. Job number 10 is scheduled to run on Saturday, January 30th. We can see the time information and the year, in this case, 2016. I can see job number 12 is set to run on Wednesday, May 27th. And we can see here at 1:44 it's supposed to run. That's 13:44 military style time. That's 2015. And again, of course, it's going to run as root just like job number 10 is, because whoever submitted those jobs was logged in as root when they were submitted. Now, the only thing about this is I don't know what the job will do. So what I want to figure out is what will job number 10 do when it runs on Saturday, January 30th. To find that out, I'll type @_C space and then the job ID, which in this case is 10. When I press enter, you'll notice that there's a lot of environment information listed with this job. So what this means is that the environment that was effective at the time when I scheduled the AT command is stored as part of the job. So it's saved with the scheduled job. However, you might wonder, where are the commands that will actually be executed? They're listed at the bottom of the output, whether it's one or more lines. Here, I see two lines at the bottom. The first uses the tar command to create a compressed archive, and the second one uses the echo command to write backup information to a backup log file. So that's actually what's going to happen. But I can't modify those commands from there. So if I need to actually change what a scheduled job is going to do, I need to remove it and then resubmit it. Let's talk about removing jobs from the queue. I'll start by typing clear and then ATQ once again. If I want to remove job number 10, I would type ATRM space and then the job ID, in this case, number 10. Now if I type ATQ and press enter, we can see that job number 10 is no longer scheduled to run. All we see now that's left is job number 12. In this video, we learned how to manipulate an AT job. In this video, I'll demonstrate how to work with systemd timer units. In Linux, systemd timers are an alternative instead of scheduling jobs using the old method, using cron. So with systemd timers, there are two files that work together. One is a file that has a .timer extension. The other is a file that has a .service extension. These are text files that we would create under /etc/systemd/system. I'm going to ls that subdirectory path, and we can see that I've already created a file called script10.service as well as script10.timer. Let's look at the contents of those files using the gedit graphical editor. We'll start with the script10.service file. Here we have a reference under the service section. Now within these config files, sections are notated with open and close square brackets. So in the service section, there's a directive here that says exec start equals, and then we've got the path and name of a script file that we want to execute. However, the timing information or the scheduling information is not in the .service file. That's where the .timer file kicks in. So let's switch over and take a look at our timer file. Here in the timer section, we've got a number of ways that we can determine when the job should be triggered. One is after the system boots. I've got a commented item here that says on boot sec equals 10 min. This means 10 minutes after the system boots up, we have the option of running a job. I've also got an item here that says on calendar equals mon for Monday, space 2015-*-1. This means as long as the Monday is the first day of the month in any month in 2015, we want to run the job. Then I've got timing information that follows that for 10 a.m. Down below, I have another on calendar example, which references that the job should run every 15 minutes. So the statement is on calendar equals *:0/15. Let's go back to the command prompt for a moment, because we might need to refer to the manual pages when it comes to the syntax for systemd timers. I'm going to type man space 7 space systemd.time because we're looking for syntax help, not help on a specific command, but rather help on syntax. Now that we're looking at the manual page for systemd.time, I see that it explains some of the time spans that can be used when we're using systemd timer units. For example, we can use U-seconds, which is referenced as USEC or US. These are microseconds, millionths of a second. Or we can use milliseconds, thousandths of a second. We can use seconds, minutes, hours, days, weeks, months, and years. So what we're seeing here is we can get much more granular with the systemd timer unit than we could when we were scheduling jobs in the past using cron. Cron could only get as specific as 1 minute. That's it. But here we have much more flexibility. As I continue down through the man page for systemd.timer, I can see I get examples on how times are treated and how we might work with on calendar events and so on. I'm going to press Q to get out of that man page. We can also type at the command line system ctl space list dash units. What this will do is list all of the units or jobs that are configured to be activated. And I can keep pressing enter to go down through line by line by line. Now, as I go further down through it, eventually we'll see that some of these items are running and some of them have not been able to load. There's some kind of a problem, and so therefore they have failed. We also have the option, I'll press Q, of grepping that large list of listing units. What we can do is grep it in our case for script 10. Here I can see that we have a timer called script10.timer, and it looks like it's loaded and active and waiting for jobs to do. In this video, we learned about systemd timer units. In this video, I'll demonstrate how to work with systemd timer units. In Linux, we have a number of ways that we can schedule commands to run. One is using cron, a second is to use AT, and our current topic, thirdly, is to use systemd timer units. Systemd manages services in modern Linux operating systems, but we can also use it to define timers. So that means that we could use systemd timers as an alternative to scheduled cron jobs. Here we're going to focus on systemd using timer units for scheduling purposes. Let's begin by taking a look at the contents of an existing script file. I'm going to type cat space / user files / scripts, and the script we're interested in is called script10.sh. This is a very simple bash script that's going to echo a message along with the date to a useractivity.txt file under /user files, and then it'll use the who command to show us who's logged in, and all that gets appended to the useractivity.txt file. So that file will grow in size over time. If I type pwd, we can see that on our Linux system, we're in /etc/systemd/system. In here, we have to create files. One is a .service file, and the other is a matching .timer file. The timer file activates and controls the .service file. I'm going to switch over to the gedit graphical editor, where I've got the script10.service file open. Again, that file exists inside /etc/systemd/system. I'll type ls script10 asterisk, and we can see here that we've got a file called script10.service. Let's examine its contents here. Here it's got a heading called unit, where it's got a directive called description with a brief description of what the script does. Then there is another heading section in square brackets that's called service. Here we're defining this as a simple type of service. Then the exec start directive points to the path and file name of the script that we want to execute. Finally, in the install section, we've got a wanted by directive that says equals multi-user.target. That's where we're going to end up having symbolic links to run our service. We'll look at that in a moment. Let's now look at the corresponding script10.timer file, which is in the same subdirectory /etc/systemd/system. In the timer file, we have a unit header section at the top. So the word unit is enclosed within an opening and closing square bracket. Here again, we've got a description directive. And here my description says execute script 10 every minute. Now in the timer section down below, we have a number of commented items. There's a directive called onBootSec equals 10 min. So after boot, we could wait 10 minutes before executing our script. We've also got an onCalendar entry here, whereby the onCalendar entry appears to be attempting to run our script at 10 a.m. on the first day of any month in 2015, as long as it's a Monday. However, that line is commented out, as is the next line, which says onCalendar equals *:0/15, which means every 15 minutes. Instead, what's going to happen is our script is going to execute every 10 seconds. So I guess I'll change the description at the top to say every 10 seconds. So it says on unit active sec equals 10s. Again, that means 10 seconds. Now this is interesting because cron jobs can't get more specific than every minute. Finally, the unit directive here says unit equals script10.service. So there's a reference in the timer file then to the .service file. Now remember, both of those files have to be created in /etc/systemd/system. Now the next thing we need to do is we need to enable our service file. Enabling the service file will create the appropriate symbolic links. So I'll do that by typing systemctl, that's the system control command, space enable, and I want to enable the service that I've created for script 10. So I'm going to type in script10.service. And now I can see that it's used the ln-s command to create a symbolic link under the multi-user.target.wants directory. That's why if we go back to our script10.service file here in the gedit graphical editor, that corresponds to the wanted by. It's pointing to that subdirectory. That's where it's going to find the appropriate symbolic link files. However, back at the command line, now what I need to do is I need to make sure that I start my script10.service. So I'm going to type systemctl space start space script10.service. At this point, I'm going to keep my eye on /user files /user activity.txt. That's the file our script is supposed to create. Every 10 seconds, it's going to keep appending content to this file. So we can see what this is doing. We can see our last timestamp was Wednesday, May 27th, 14:30 and 17 seconds. If we cat the file again, we now see it's 27 seconds because it's set to run every 10 seconds. And if we make sure we wait at least 10 seconds and cat the file again, now this time we've got 37 seconds. So what we're seeing is that we can use systemd timer units as an alternative to scheduling jobs where we might have used cron in the past to accomplish this. In this video, we learned how to work with systemd timer units. In this video, I'll demonstrate how to convert a cron job to a systemd timer unit task. Cron jobs can be configured for recurring items that we need to run, either at the user level or at the system-wide level. Here, I'm going to type cat/etc/crontab to view the system-wide crontab file, where at the bottom we can see we have an entry that is set to execute script11.sh as user root, apparently on Thursdays and Fridays, that would be day 4 and 5 of the week, at noon. So what I want to do is I want to not have that run any longer as a cron job. Instead, I want to configure it as a systemd timer unit job. So the first thing I'll need to do then is to prevent that from running as a cron job. And one way to make that happen is to open up the /etc/crontab file and simply either remove or comment out the job that you're going to convert to systemd. Here, I'm going to put a pound symbol in front of my scheduled job for script 11. And I'll press escape, :WQ for write and quit. And at this point, that is no longer a scheduled cron job. I'm going to bring back the cat command with my up arrow key so we can verify that that change did take place. And indeed, it did. Now, when you want to work with systemd timer units, you need to work with a .service file and a .timer file. I've already created these and opened them up in the gedit graphical editor. The .service file and the .timer file must both be under /etc/systemd/system. You could even have multiple service files that might run different jobs affected by the same timer if appropriate. Let's start by talking about the .service file. Here we've got a header called unit, and headers are always enclosed in square brackets. Under the unit heading, we've got a directive called description, and then that's followed by an equal sign with a description. In this case, the description is simply script 11. Then further below in the .service file, we have a service heading section, and again it's in square brackets. Underneath the service heading section, there's a directive called type. So it says type equals simple. This means that I want to treat the job as a recurring job and not a one-time only type of job. Under the type directive on the next line, we have the exec start directive. So it says exec start equals, and then it's got the path and name of the script that I want to execute. Further down below, I have an install section, where there's a directive underneath that says wanted by equal multi-user.target. That means that there will be symbolic links to start this in accordance with the timing that we will configure in the timer file under the multi-user.target subdirectory. That is a subdirectory under /etc/systemd/system. Let's switch over to our .timer file. In the .timer file, we've got a unit heading section with a description directive underneath. But then we've got a timer section. Remember, sections are denoted with open and closed square brackets. Under the timer section, I've got a directive that says on calendar equals mon-fry, that's Monday through to and including Friday, space 2015 ***1. So this means that within the year 2015, I want to make sure that the Monday to Friday when I want to execute this job happens to be on the first day of the month. And if it is, I want the job to execute at 12 o'clock noon. So then space 12:00:00:00. Under the on calendar directive, I've got a unit directive that equals the name of my service file, in this case, script11.service. So essentially, I've recreated what I was doing before with cron, except here within systemd. With systemd, we have much more flexibility in terms of specifying the recurring schedule with years or even milliseconds or seconds, because remember, cron can only get as granular as running something every minute. So at this point, once I've got my .service and .timer file, it's time to enable and start them. Now with the command line, I need to enable and start the service based on the settings in the service file. To do that, I'll type in systemctl space enable space, and my service file in this case is called script11.service. I can see from the resultant output on the screen that it's created a symbolic link for that under the multi-user.target.wants subdirectory. Now what I'll do is make sure it's started. So I'll type systemctl space start space script11.service. And at this point in time, we have now converted our previously scheduled cron job to a systemd timer unit task. In this video, we learned how to convert a cron job to a systemd timer unit task. This exercise focuses primarily on aspects of the file system as well as with scheduling jobs. Specifically, in this exercise, you'll begin by finding all files on the system that contain a specific username. Then, you'll list the file ACL's access control lists for your home directory. Then, you're going to create a script that will list any executable files in your home directory. Then comes the scheduling tasks, beginning with scheduling a job using the AT command, scheduling a job using cron, and scheduling a job using a systemd timer unit. Pause the video and give these a whirl, then come back to the video to see possible solutions. Okay, here's how I would approach the exercise tasks. The first thing we were asked to do was to find all files on the system that contain a specific username. I'm going to use the grep command for that. Take note, I am in the root of the file system. We can see that in my prompt. So I'm going to type grep space -R. I want to perform a recursive search starting from my current position in the hierarchy. And then in quotes, I'm looking for a username that ends with Powell, so I'll search for Powell in double quotes. And after that, I'll put in an asterisk. When I press enter, it's searching for files where within the content of the file, it has the text Powell. I'll press Control-C to interrupt it. The next thing we needed to do was to list the file ACLs for our home directory. One way to do this is to type get FACL space, and if I want to look at the ACL for my home directory itself, I could use the tilde symbol, which references my home directory. When I press enter, it shows me who the owner, who the group is, what their permissions are, and any other users or groups that were given permissions. I can also type get FACL space tilde /star. This way, I am getting a list of the ACLs for all of the files in my home directory. I'll clear the screen with clear. The next task we were asked about was to create a script that will list any executable files in your home directory. I'm going to switch over to the gedit graphical editor, where I've already got a file called executables.sh. This shell script exists in /userfiles/scripts. This is one way that we could search for executable files. In this script, we are using the find command to begin searching in the home directory, and only in the home directory, so I've used -max depth space 1, because remember, find is recursive by nature, but we were asked only to list executable files in the home directory. I'm going to use -executable, which will identify files flagged as executable, and we were asked only to list files, not directories, so I've added -type space F. We could also have used the test command with the -lowercase x switch to test for executables as well. Let's run this script to ensure it retrieves the correct results. So what I'll do is I'll run /user_files/scripts/executables.sh. Here it's cleared the screen and it's showing me a list of executable files in my user home directory. I'll type cd space tilde and press enter to go to my home directory, where I'm going to type ls-l just to test our work here. And we can see, in fact, that those files that were returned are indeed flagged as executable. Here in Red Hat Enterprise Linux, they show up as green text. That means that they're executable. The next thing we were asked to do in the exercise was to schedule a job using the AT command. The AT command is for one-time jobs. To begin, I would type AT or at space, and in this case, I want something to happen at 9 p.m. on Friday. So I'll type in 9 p.m. space Friday. When I press enter, I'm placed into an interactive AT prompt. All I want to do at that point is reboot my Linux system. So I'll put in the init space 6 command and press Control D. Now I can see that that job has been submitted, and I can verify that it's queued up by typing ATQ. Indeed, there is job number 13. Next, the exercise wanted us to schedule a job using cron. So in this case, I'll schedule a user cron job. To do that, when I'm logged in as a user, I would type cron tab space -lowercase e, so I can edit my cron jobs. There are none currently configured, so I'll press insert, and I'm going to type 30 space 22 space asterisk space asterisk space asterisk. The 30 means 30 minutes. The 22 means the hour. That's 10 p.m. So at 10:30. And the other three asterisks mean I want something to execute at 10:30 any weekday, any day of the month, every month. What I want to execute is a script under /user files called backup.sh. I'll press escape and :WQ to write and quit, and I'll type cron tab -L for list. And we can see, in fact, that the job has been scheduled. Finally, the exercise asked us to schedule a job using a systemd timer unit. Let's begin by taking a look at the script that we're going to schedule as a systemd timer unit. Here in gedit, I've got a script open called tcp_stats.sh. This script is going to append the date to a file, then it's going to do an ifconfig, where it's going to filter out lines that contain inet and lines that do not contain inet6, and it will append that to the same file. Then it'll run the netstat command to get network statistics specifically for TCP, and it'll put that in the TCP stats file. So this is the core of what we're going to do. We're going to schedule this to happen hourly as a systemd timer unit. Now that means that in /etc/systemd/system, we've got to have both a .service file as well as a .timer file. Here in the .service file, I've got my unit header with my description. I've got my service header, where this is set as a type of simple. I've got my exec start directive, which points to the specific script that I want to execute. And for the install header, I've got it listed as wanted by multi-user.target. That's where the symbolic links will be created. If I take a look at my related .timer file, in the timer section, I've got the on-calendar directive, where it's set to run every 60 minutes or once an hour. For the unit directive, it's pointing back to my tcp_stats.service file. Now, once that's taken place, what we need to do is we need to enable the service and then start it. So this we can do by typing systemctl space enable space tcp_stats.service. That's the service file that we would have created. The next thing I do after it's created the symbolic links is I would type systemctl space start tcp_stats.service. In this exercise, We worked with various aspects of the file system as well as with scheduling jobs.